Hello, so we are making a video for our product for the course ET801. We are teaching mathematical identities and equations in a visual way by using 3D objects, modeling and animating them. So we'll show you our product and how it actually works. So my name is Prashant and my teammate is Lokesh Dhundara. We are team 7. Okay, so here we are using the software that is Autodesk Inventor. So, so over here, our main objective is to teach the mathematical identities, which are basic identities such as a plus b the whole square. So here we have a identity which depicts a plus b whole square. So this is a square which is a plus b, and that is x plus y and x plus y. So we have even denoted the individual parts over here and the lengths, and here we are going to show you how to animate it. So even in this animation panel we have a control over the uh, speed at which the animation does, and also we can do it in a single way animation or a reverse direction or two in one. So we'll show you the forward and reverse animation at once. So Lokesh will now animate the equation. So this is how we can show students that a plus b the whole square is individual sum of y square plus x square plus x into y and y into x. So this makes the expansion meaningful to the students. And now we can see we have reverse animated it also. So similarly, now we next represent it for a plus b plus c the whole square. So this here we have the equation a plus b plus c, that is x plus y plus z whole square. So this is a square with dimensions x plus y plus z, and these are the individual parts. So now we are going to animate it. So now we can see individual parts are coming, and also will decrease or decrease the speed at which the parts are coming. So now we'll apply it again and then we play it again. So now you see the speed has decreased. So teacher can control the speed of the parts so that if she requires a larger time to explain to students, or if she wants to just show them, she can decrease the speed. So this is a plus b plus c, that is x plus y plus z whole square with all the individual parts, that is z square, x into z, y into z. And as we can see, we can even control individual parts. So once we do one part is done, we can pause it again, we can again play it, we can again pause it. So the animation is totally under our control. So now we next go to a plus b the whole cube. So over here we have a cubic frame. The cubic frame is named, the dimensions are mentioned. So we'll once zoom it at the one of the corner so that we can see. So this one side is b cross a, so all the parts of this cube are b cross a. So now we'll zoom out again a little bit so that we can start the animation. So now these are all the individual parts. So once we start the animation, so we have the animation started. So now we can see individual, and the best part is teacher can, to give a very clear view of the animation, teacher can actually control the direction. She can rotate the whole diagram in 3D space to let the students get a clear idea of what exactly which part is coming and joining into the frame. So now we can see individual parts coming, and the colors are also used or vibrant so that even students get interested to look at it. Things look attractive, and people or the students get interested. So this was a plus b plus c the whole cube. So we'll again open it again, the cube. So this is the reverse animation. So again they are coming out, and since we can see all the sides labeled as a discussion part of our peer assessment or during the presentation, we were asked to label individual sides so that students can know which particular part is coming. So we have labeled every part right now, and we can see students can identify which particular part is coming out of them. So this is the identity. So presently we represented three basic identities, which is a plus b the whole square, a plus b plus c the whole square, and this is a plus b the whole cube. These identities, if generally taught, they are taught in a rote learning or let's say memorization method, but this procedure can actually make the students understand it with full details, like why the equation and its expansion are equal. So next, now we go to a equation. So apart from the normal identities, there is one simple quadratic equation which is 2x plus 1 into x plus 4. So this is a wireframe which represents the complete area, that is 2x plus 1 into x plus 4. And now we'll be deconstructing this particular solution so that students get to know what exactly is the answer for this. So here we can see the individual parts of the solution, and once we start the animation, so let's say all the parts are coming, these all are the x into 1 parts, so these all comprises, and there comes the constant variable constant parts, and then also the x square. So now the equation is formed, and these corners have also been labeled so that students get an idea which side depicts what. There is 2x plus 1, this is x plus 4, so this is the complete equation. And this is the perspective which teacher can take and show the students. Apart from this, let's say teacher wants the students to practice, so now we'll show what can the students get. So this is the standard equation which we showed already. So this is expansion of x plus y the whole square. So once the student are given, student can actually drag and drop on their own, so students can be given to play with this. So they can be given individual scattered objects and asked to fill the square, so using appropriate squares or appropriate parts. So let's say here, as a student, he is filling the total frame which depicts a plus b whole square. And now once he puts all the parts inside, he observes that to complete the square which depicts x plus y the whole square, he has used four squares, that is four smaller squares, which are y square, x square, x into y, and x into y. So there he gets a equality idea or a relation between the complete identity and its expansion. So this is how we aim to learn, or we aim to teach the students. And during the presentation we were asked to make few more equations. So here are few more equations which we made. So this equation is x plus 1 into x plus 5. So this particular side, one side is x plus 1 and x plus 5, and these are the individual components which the students will be having to drag and drop. And the next equation comes to be x plus 1 into 2x plus 1. So this is again one more frame which students need to fill with the components provided to them. And similarly there is one more. So this is 3x plus 1 into 2x plus 1. So this is the solution part. So there are 5x squares and 5x into 1s, and there is one constant. So, and there is one more equation which we made, that is this is x plus 4 into 2x plus 1. So this is one more practice problem which can be provided by the teacher to the student. So this is all what we made, and we expect that this will result in a meaningful learning for all the students rather than just rote learning. So this will give them as a fundamental strength a great knowledge about how the mathematical equations can be graphically represented, why they are why the equality exists, and how they can represent it graphically. And similarly we only did for square equations, that is quadratic equations, because considering the 8th grade students, a cubic expansion of equation in a three-dimensional space will be difficult for them to understand. So at this point we thought stopping at quadratic equations will be better. So thank you for the opportunity to give us to make this project, and hope the project is totally uh, understood via this video. Thank you.